Okay, this video is going to walk you through the 4 problems of today's warm-up, starting with number 1. What you see in number 1 here is a quadratic formula. There are 3 ways to solve quadratic formulas. One of them is by the graphing method, one of them is by factoring, and the third way is by quadratic formula. If you try to graph it or solve it by graphing, you'd graph the left side of the equation by putting this in your y1 equals, put this part right here in your y2 equals, and see where they cross. On the x-axis, they're going to cross at 2 coordinates at 2 and 6. Those happen to be your solutions. If you solve it by way of factoring, you could do a box and diamond, get it down to 2 pairs of parentheses where you have x minus 6 and x minus 2 equals 0, and then ask yourself, what do you put in for x to make this go to 0 and make this go to 0? Again, your 2 answers would be at 6 and 2. If you do the quadratic formula, you're going to put in a, b, and c for your quadratic formula, where a is 1, b is negative 8, and c is 12. Then after putting that into your calculator, use the quadratic formula, you'll get answers also 6 and 2. Those are your 2 solutions to the quadratic equation. Also remember, when you have an x squared equation, you should be looking for 2 answers as well. Next, number 2. This is a fraction buster question. Fraction buster questions are found by trying to figure out a common denominator between all your terms. 4, 3, and 6, they all go into 12. So you want to change all your denominators into 12s. Then you look at each term and say, what do I multiply this denominator by to get a 12 right here? That answer would be 3. So I multiply the top by 3 and get 3x. What do I multiply the 3 by to get 12? That would be a 4. So I get 4 in the numerator there. What do I multiply 6 by to get 12? That would be 2. So I multiply that by 2 and get 10 in the numerator. Then I cross out all my denominators and then rewrite the new equation. Once I have my equation like this, I'll subtract 4 to both sides, and then I can then get my new equation, 3x equals 6, and then divide by 3 to both sides and get my final answer of x equals 2. Now, if you're still trying to use the calculator method that's emphasized in this chapter as well, you may have done it this way possibly also. You could have then took this left side of the equation, put that in your calculator, which is an equation for a line with a slope of 1/4 and a y-intercept of 1/3. Then I could also graph the right side, which is going to have a horizontal line at 5/6. If you did those two, they would cross at the coordinate 2, 5/6. But again, when we're trying to solve equations that only have x in the equation, we want to make sure we're only using the x part of the coordinate, which is just 2. As you can see, that was our solution algebraically as well. Next, if you want to solve this next question, it's an absolute value problem. We solve absolute value problems algebraically by getting the absolute value bars alone by themselves. So in other words, this 3 needs to get out of here. So you're going to divide it by 3 to both sides. Now that you have the bars alone, we can make 2 equations. X minus 5 equals positive 6, and x minus 5 equals negative 6. To solve those equations, you're going to first of all add 5 to both sides, and then get the answer of x equals 11, and then add 5 to both sides in the other equation, and get x equals negative 1. You've now solved it algebraically. But you also may have tried to solve it with a graph as well, just to show that there's another option you could have used. You could graph the left side, which is an absolute value graph that shifts just 5 units to the right and is a little bit more stretched or skinnier. And the graph looks like this. If you graph the right side, it's 18 for your y2 equals, and then graph that. The 2 graphs will cross at 2 coordinates. The 2 coordinates happen to be negative 1, 18, and positive 11, 18. Again, if you're solving an x equation, you're only going to take the x part of the coordinates of where they cross and put those in as your answer. So those are my 2 answers that you did algebraically and also graphically. Number 4, that's a square root graph over here that we're trying to solve if we're going to do it graphically, but in this case we'll start out algebraically first. If you're going to do algebra, you're going to get this 4 out of here first by simply adding it to both sides. Then I want to get rid of it, and then I get this new equation of 3 times the square root of 8x plus 1. The next thing you need to think about getting rid of is this 3. By getting that 3 out of there, you have to divide it to both sides, getting a new equation that now reads like this. As you can now see that the square root is the next container that we need to get rid of, the opposite of square rooting something is to square both sides. If I square both sides, now I've got 25 on the right side. Then the last 2 steps are to get rid of the 1 by subtracting 1 to both sides, and then divide by 8 to both sides, and you finally get the answer of x equals 3. If you want to solve it graphically, you can also see how that works as well by graphing the square root graph. It shifts. It's going to be kind of hard to see, but it would be negative 1/8 to the left and down 4. That graph shoots up to the right like this, and then it crosses the horizontal line at 11 by hitting the coordinate at 3, 11. Again, when you're solving an equation graphically that only is for x, you only care about the x part of the coordinates. So again, the answer is just 3, as you also got algebraically. Last of all, I want you to try to take this equation now and change the inequality in number 3 and show your calculator, or show on your paper what the answer should look like if this is now a less than or equal to symbol. Pause the video now and see if you can get the answer. All right, now that you're back, hopefully you've got a chance to see the solution. If you realize that inequalities are not any different than equations, you're going to still find the boundary points. The boundary points at 11 and negative 1. They go on the number line. So you put those in the number line. You hopefully put them in numerical order too, so the smaller numbers on the left, the bigger numbers on the right. Then look at the inequality. Do I want to include it or not? This one's got an equal sign, so I want to include the dots or the boundary points, so I make them solid dots. The next thing I need to do is test out 0. 0 is between the two numbers in this case. If 0 works, we're going to connect the dots. If 0 does not work, the arrows will go outward. In this case here, if you try out 0, 0 minus 5 is going to give you negative 5. The absolute value of 5 is positive 5. 5 times 3 is 15. And then 15, is that less than 18? The answer is yes. So since 0 did work, we're going to connect the dots. Next, you're going to try to say the answer algebraically as well, so that you can say that as well like this, like you did with domain and range. Negative 1 is less than or equal to x, which is less than or equal to 11. Now try to change the number 4 question into a greater than symbol. Pause the video now again and see if you can solve and show the answer like this graphically if it's a greater than symbol. Alright, hopefully you've had a chance to try that and work it out. You're going to take this boundary point, solve it you solve inequalities the exact same way as equations. So you're going to find the boundary point first. The answer is a 3. Put that on the number line. Next question is, do you include it? Since it's a greater than symbol, you're not going to include it by showing it with an open circle. Then you're going to decide, does 0 work or not work? So 0 is on the number line on the left side here. So if you try out 0 here, 8 times 0 is going to give you 0. 0 plus 1 is 1. 1 times 3 is 3. 3 minus 4 is negative 1. Is negative 1 greater than 11? The answer is no. So our answer should go off to the right. Then finally, to say the answer, you're just going to say x is greater than 3. Hopefully your solutions worked out the way these did, and in the future you can hopefully be successful with inequalities. Good luck.